My name is Brian Bell. I'm a client-side technology manager at the Nerdery. We've got a booth out back here, and I'm working at the headquarters office in Minneapolis, Minnesota. Thanks a lot for having us today. Today we're going to talk about how to avoid turning your code base into a box of bees. And we're going to talk about Sass. We're going to talk about architecture. It's going to be an exciting talk. So let's get into it. Modern client-side tools are abundant and powerful, with preprocessors being one of the greatest advancements to date for CSS. However, in practice, these tools are only as smart as the client-side architects who wield them. We're going to look at several techniques for how Sass can help you apply a modular way of thinking to your site's CSS file structure that can be configured both to support modern web design practices and legacy code bases. This consists of three main points. First, we're going to discuss methodology. Talk about what that is and why that's important. Then we'll talk about this thing called objects. We've been discussing that a lot today already, and I'll give you my take on what that means. And finally, we're going to look at structure. Once we get into structure, we're going to get in the weeds, and it's going to be a lot of fun. But be prepared for that. Before we get into that, I want to take one quick note on responsibility. And when I started as a technology manager at the Nerdery, my boss came up to me and she handed me this card. And on the front of the card it said, "You are an adult." On the back of the card it said, "comma bitches." Like I needed a reminder that I was an adult. Been a web professional for many years. We all have been. We've been doing this for a long time for our clients. We have to deal with budgets and timelines and other developers and project managers. We need to do things in a responsible way, be an adult, and for some reason, us web nerds, like we need kind of those reminders every now and then. We don't get to just play around on our computers and make willy-nilly decisions in our code bases. We need to be responsible. So we have a responsibility to three things. If you're an employed developer, you have a responsibility to your employer. We need to help make them money. You want to stay employed, right? We need to be responsible to our clients. We need to help them make money. You want your clients to bring you more work. That's kind of the goal of this. And we have a responsibility to the internet. It's a big, intangible, digital conglomerate, but it is our livelihood. It is what we do every day. So we might as well make it an enjoyable place to work. We might as well be responsible, good stewards of the web. And if it explodes, if the internet dies tomorrow, we all have a job in finished carpenting. We can be carpenters because we pay so much attention to details, right? Beyond responsibility, we are responsible, when you're irresponsible with this power, you end up in a bad place. So without proper planning, maintenance can be really hard, right? For example, changing the z-index of something in a code base that is not organized is a very scary thing. We need to come up with a better plan for our code base, for maintaining websites. So this plan is called architecture, right? CSS by itself has several hurdles that we have to deal with. It's declarative, meaning it does not logically follow by default. So maybe you have a selector with some properties on it. Looking at that one little piece of code, you don't really know what it's affecting, what other parts of the code base are affected by that. It operates in a global namespace, which means collisions are a real thing. Specificity, looking at Sass, talking about variables. It utilizes inheritance, which necessitates planning. If you're going to inherit well, you need to have a plan for that. And it operates in the specificity model, which again, collisions are a real thing that we have to deal with, especially at scale on large projects. So how do we go from this guy fighting with his code base to this guy? Look at him. He's the architect. We can combat that with preprocessors, right? So we've been missing some stuff in CSS for a while. When we have to maintain code bases, when we have to do this repetitive task, we have to go in and make a small change. That gets scary when you have one big, giant, flat style.css file. So Sass gives us a few things: variables, functions, mix-ins. Imports the right way, right? We're importing before the code is rendered in the browser. So we're not piling on HTTP requests by separating our code out in CSS. We do it all beforehand. We pre-process it through and pump in one style sheet to the browser. So, all right, we need a plan. We need to stay organized. We're responsible. Well, how do we do that? Well, let's just use Sass, right? Cool. Well, your plan cannot be simply breaking your Sass or your CSS apart into separate files. What does that look like? That's a box of bees. All right, we're going to hit this hard today. You open that up, you get stung, right? You try and dig into that folder and make a change. Like it's sharp, right? There's pointy bits in there. You don't want to touch that. So we have a very powerful programming language, but how do we stay organized with that programming language, and how do we architect well? Well, the answer is very easy. We need to make time for it, right? That's the answer. That's a very hard thing to sell, though, especially when you're a web professional. You only have so much say in how much time you have. So we're gonna look at a way today to set up your code base that you can reuse a whole bunch of times. That some initial investment in this architecture is going to go a long way. So, architecture, 2 parts. One is a bias, which we call a methodology. We're all pretty familiar with those. Second part are objects, and again, we'll get into that in a minute. First, we're going to discuss the idea of a bias, okay? And the reason we have these is because of responsive web design. Before responsive web design, we did not need to care about viewports. Like, there was only a few viewports. We had desktops and some laptops, and that was kind of it. As soon as we introduced tablets and phones, we need to deal with our content at varied sizes, at varied viewports. And that's responsive web design. So that necessitates us to have more of a plan for our code base and to build in flexibility into all the things that we're doing. So a few methodologies, we've heard about these today already actually. Atomic design is one, object-oriented CSS, SMAX. There are a number of others, probably dozens of others. For example, Doxa is a new one that's kind of emerged. IT CSS, we've got a lot of information about that one, but no real documentation yet on that. Functional CSS, classy CSS, these are all ways of thinking about CSS in order to build code. So why do we have so many? Why do all of these different methodologies exist? Well, it's because there isn't one single answer, right? We have lots of different things we're dealing with as professionals. Every project's different, every client's a little bit different. Your restrictions are a little bit different every time you open up a new code base and start building. So all these methodologies are great. It's really cool that people are spending time devoting to thinking about how they can organize and architect their CSS in a way that makes sense for them. So today I'm not going to push any particular methodology. I will tell you mine. But what we're going to look at will work with any of the methodologies out there. So I'm not saying you should subscribe to what I do, but if you use one of these other ones, it will still work. And why do we use them? Well, in this talk, we're using them to avoid the bees. All right, we want to get rid of that. We don't want bees in our code. Behind each methodology is this kind of innate desire to separate concerns. And again, we've touched on this a bit today. Generally, what this means is code is given the luxury of focusing inward. Okay, so let that sink in for a minute. Objects should only be concerned with themselves. Okay, they serve a single purpose. They are intended to do that one thing really well. Call them components, call them modules, call them objects. It doesn't necessarily matter, but the thing we're looking at here is, in order for all the rest of this stuff to work, objects need to be looking inside of it, like into themselves, focusing inward. And what I mean by that is, we don't push other things away by putting margin on the outside of our objects. We handle overflow properly if we expect some content to overflow its container. So each methodology nuances this separation of concerns differently. And here's one we're going to look at today. It's made up of a number of categories. We'll go through them quickly. Base. This is your reset, your normalize, whichever one you prefer to use. Also in here I'm including elements if you're going to style the body tag or you're going to style some base text links. That's in base. Next one is landmarks. These are signposts. All right, this is your header. This is your footer. This is your primary navigation, right? These are things that show up once per page by design, right? That's the way they've been built by the designer. And we don't expect those objects to be reused on the same page. All right, those are, obviously they show up on every page of your site, but they're not, you don't see two headers on your site, you see one. So we have a little bit of freedom there to be flexible and not forcing our objects we identify elsewhere to deal with what we see in our header. Often it's unique, right? You have a logo and a search bar and some buttons and a navigation that drops down that you only really see in that one place. So we're going to give you freedom in the landmark category to write code that's not necessarily reusable. Okay, I think that's okay. Another one is theming. So in our case here, we're looking at accessibility options, right? So making the font size bigger, applying higher contrast to your code. These are themes that don't change the content. They don't change the structure of your code or what you see on the screen, but they do change some visual aspect of it. Something like enhancing the font size for the visually impaired, or increasing the contrast for those that are colorblind. Next one, layout. We're going to hit this one hard today, and what I mean with layout are things like the grid. All right, that's a very familiar object to us, and another one that I like to use is vertical rhythm. Think of a grid, but flip it horizontally, right? So the space that things have between them as you go down the page vertically. Grid does horizontal. Vertical rhythm does vertical. Containers. These are things like alerts, features, the media object. We looked at these a lot today, and anything you'd put in a box, right, that's a container. That one's a little bit squirrely. It's kind of the wild, wild west category, but it can hold a lot of things. Repeaters. This is an interesting one. Think of your vertical lists and your horizontal lists. We looked at tiles earlier, or blocks, whatever you might call that. Those are things that are by design intended to repeat infinitely. All right, so we can build those as individual and interesting objects that repeat very well. Like that's their goal, that's what they do. And we'll give those their own category. And finally, content. These are things like your icons, your buttons, your headings, your text styling, the actual visual bits on your page that you get to style. So those are the 7 categories in my way of thinking about the methodology. I don't have a name for it, it's something that we use. These are really great for when you identify an object on the page, it almost will always fit in one of these categories. So we'll come back to methodology in a moment. Next up, we're going to look at objects. Our example object for the day is the grid. The grid is a layout object. And a grid, this object is a combination of HTML and CSS at its base. Sometimes we use some JavaScript in there. Sometimes we don't. It doesn't necessarily matter. But objects are identified patterns that can be abstracted for high reuse. And they're fully encapsulated logical entities that are easy to extend, right? They're also extremely portable. We want to be able to move these things around. And if objects are carefully written, you can put them together in any number of ways without having to write additional CSS. So our grid object, it looks like this, right, when you put it up in the browser. It's got columns, it's got gutters, and it has a parent container. So what makes an object good? All right, we talk about what it should do. Well, how do we actually identify a good object in code versus a bad object in code? Here's a few examples. They use classes, not IDs. There we are. We try and keep our specificity low. So the ideal selector in my mind is a single class, right? That's low specificity. It's very easy to override by design as we intend to move and expand our object. Elements get tricky. Single class is probably the best way you can build an object. We avoid contextual selection. So things like class space div or class space p, right? That's a contextual selection of the element that really limits what that element can do, right? So we want to avoid contextually selecting anything. We want to avoid overqualification. So that's the flip, right? Div.class with no space. So we're chaining those things together. That means our class only works on a div. We don't really want that. We want to give flexibility to our class, so we eliminate overqualification. And we want to avoid elements in our selectors. This one's not always possible, but this is a goal that we should try and strive for. And the aim, the most important one is aiming for encapsulation. That is that focusing inward that we mentioned earlier. And again, I'll just repeat this, that is kind of the basis for the rest of this to make sense, right? If we can encapsulate well, all the rest of this will fall into place and your code base will not have any B's in it. All right, so we got 11 goals, right? Because client-side is really easy. So we'll go through those. Semantics. What is semantics? Well, we're providing meaning to the content of the page, all right? We have all these elements we get to choose from in HTML5, and they all have different meanings. Well, that's what semantics is. The grid is not a semantic object, but we'll get to that in a moment. Accessibility. We want to look at, can screen readers find the content on your page? Can they actually consume all of your stuff? Is your object predictable? Don't be clever, all right? That's something to remember. If you write a clever object, it will bite you later, all right? You might think it's a really interesting way to solve it with CSS and maybe build some very elaborate thing, and that's great until you need to make a change that your cleverness doesn't support, and now you have to refactor and build it again. Reusability, or encapsulation, that's essentially what that means. Can you put this object anywhere? Can you reuse it in multiple places? Flexibility. Thinking about responsive web design, is your object kind of width agnostic? Will it flex and move depending on what container you put it in, right? If you have unpredicted content flow into your object, will it flex and deal with that additional space? Resilience, speaking to that content coming in that you don't expect. Think of resilience as like your quality assurance department, right? That's their job, is to prove the resilience of your objects. If you have a button and it's a one-word button and you build it to only allow one word, it's not a very resilient object. Can your button accommodate 2 lines of text? You build a button differently if you need to think about that. Is your object understandable? Can someone else come into your code, read your code, and understand what's going on? That is an incredibly important thing when we work on teams. It is an incredibly important thing when we work with a project we know that will go into maintenance mode after we're done, right? You have to be able to understand the code. Is it scalable? Can I use this object on really big sites? Can I use it performantly on a lot of different sites? How many on a page can you handle at one time, right? Scalability. Is my object built where if I put 100 of them on a page, my performance is going to like suffer? Or am I using low specificity where I can have that many and the page still hums along nicely? Is your code maintainable? How easily can changes be made in the future? Did you give your future self a high five with your code? We'll find out. Is your code performant? Speaking of selectors, there's a little bit of performance that we have there. There's some capability we have there. But really what we're talking about with performance is the size of your code base equally balanced between flexible and you can do a lot of things with it, and it's not too large where you're contextually styling and picking everything up, right? We want to build the appropriate sized code base for the task. And interoperability. What that means is at a company, if you're the front-end developer and you build something, can you take what you built, give it to someone else, and they can pick it right up and keep moving with it? Is it interoperable? Can what you're doing bounce between a bunch of different people? When you do that, and you do that well, you provide efficiency for your clients. You can charge less. You can get things, I should say, you can charge more by getting things done faster, right? And so you're providing interoperability amongst your team. Okay, a lot of goals. Let's test our grid object. First, we're going to look at how it's built. All right, we've got a single parent class at the top, which has a negative left margin on it. And we've got our friendly little clear fix. This is the micro clear fix. And we'll start to notice as we go through here like some code Bs, right? Like these are things that we're going to deal with later, but we'll just identify them now. Both the left margin, having it be a percentage at a number, and our clear fix. When you get it scaled, that's a bit of a code B. We want to get rid of that. So we've got these two sections, the parent and we're clear fixing our parent because we're going to be using our floats as our construct for building this object. You can build a grid a whole bunch of ways. I'm not saying this one's better or worse than any other way. This is just as an example today. Our child object is the grid call, grid dash call. Children are identified by a dash, right? Well, we've got a couple more B's in here. Like, where did those numbers come from? We have really no idea by looking at the code. So we want to deal with that as well. And based on that, like we saw earlier, we've got a 4-column grid for simplicity's sake in this talk. And to do that, we underscore our child and then extend it, right? So children are identified by dash. Extensions of a class are identified by an underscore. So we've got 1 of 4. It's 1 of 4 columns, 2 of 4 columns, 3 of 4 columns, 4 of 4 columns, right? At the end of the day, every selector in this object is a single class. That's really nice, right? It's a very flexible thing, and there's only one class for each selector. We got a lot of B's there that we got to deal with, and we'll get to that. So is our object good? Let's test it out using our objectives. Did we use only classes? Yes. Is our specificity low? Yes. Did we avoid contextual selection? Absolutely. Avoiding overqualification? Yep. Are elements in selectors? No, they're not. And is it encapsulated? Absolutely. The way it's been built with our negative margin and the positive margin on our children, we have fully encapsulated this object to not push out in any direction from itself, all right? It's a very functional grid. All right, so let's see here. Let's test our goals. Is it semantic? The grid isn't a semantic object. The grid is purely layout, right? It's putting things in a place in the DOM. And usually you put it on a div, maybe use a section, something like that. But those are, the div especially is a semantic, meaningless element. Accessible, again, not something that is applied or applicable to a grid. So we'll just cross those out, pretend those don't exist for the grid object. Is it predictable? Yes. I think you can look at the naming convention, the way that it's been built, the single class structure of it. That's a very predictable object. You know what's going to be going on. You know what's happening. Is it reusable? Well, you know, that's the whole point of a grid, right? We want to reuse that a whole bunch of times. So it's been built to support that. It's extremely flexible. We're using a percentage-based grid, which is going to support our responsive design efforts. And it's going to handle any kind of content you throw in there. We've limited the width of our column, so it's going to have some restrictions built on it, so we're providing proper flexibility. Resilience. This is an interesting one because traditionally grids are not very resilient. If you build grids in the way that Brad suggested earlier, before he did it a better way, you've got this margin on the sides of your columns, and if you add more columns than your grid is meant to support, your layout breaks because your columns shift down below and now they're off kilter a bit. So the way this one's been built is very resilient. If you put more than 4 columns in a row with this grid and the 5th one wraps down to the next level, it will line up perfectly with the one right above it. So it's a resilient grid. Understandable, assuming you buy into the naming convention, assuming you know a little bit about how grids and percentages and CSS work, yeah, I think it's a pretty understandable object. Scalable, oh so very much so. Again, that is one of the primary goals of a grid object, is you can use it all over your site. Maintainable, no, this is one that we need to fix. Where did that math come from, right? Where are the percentages? Like, there's no comments. I don't understand it. If I need to make a change, I don't know where to go. And the margin offset of the parent was different than the margin on a column. Like, what is going on there? Performant, absolutely. We've got single classes. This thing will collapse down very small when you minimize it. And interoperability, another no. If you use it exactly how it's built, this is an interoperable object. But if you want someone to come in and make a change to it, where's the math? Where are your comments? If I want to add 5 columns, how do I recalculate all that information, right? That is not something that can be easily picked up and moved around between people. So let's recap real quick. We've looked at a methodology. We've looked at objects. We're going to look at structure now for a little while. So using Sass, we can apply structure to our code base. It'll align with our methodology. It'll align with the concept of objects. And it looks something like this. And in our base section, we've got, we got reset, we've got elements, we got helpers. That's kind of like a common nomenclature for if you want to put mixins or functions that you're going to use kind of throughout. You put them in helpers at kind of that root level. And then we've got our objects folder, which is great. We know what those are now, and that's part of our methodology. But what does that look like? What is that? Oh, that's a box of bees, right? That's the exact same thing that we looked at before. If you start adding a whole bunch of objects in there, it's just one flat big file of things. It's hard to find code when there's no structure. So here's a better way to do it. And we'll look at that. Beginning with base, so applying our categories, we've got a common ground. This is our predictability place, right? We get to reset all of our stuff, whether you buy into that or not. This is where you get to do that. Our landmarks, here's our signposts, things we don't intend to be reused. We've isolated those away in a separate folder. And then finally, our separation of concerns objects are categorized by layout, container, content. Repeaters would go in there as well. That is applying our methodology to our code base. Like, that makes a lot of sense, right? If you're going to ask people to buy into a way of thinking about your code, why should your code base not follow that same kind of convention, right? Cool. So we're starting to form a plan. That's great. That's some nice organization there. The last version and this version, they have literally no effect on the user of your site. They see the exact same thing in the end when they pull it up on the screen. However, what we've done here is started to move towards a more maintainable code base, a more interoperable code base. So I mentioned in the beginning that we would build a code base that supports modern web development and legacy support. So we'll look at that real quick. For modern web, we've got a couple examples. Single file, multi-file. Look at single file first. If you build media queries just right into your file, now you've got media query support. You've got a responsive code base that can do something different across different breakpoints. Cool. So we build our grid object at the root level of our file. Inside of a media query, maybe we want 6 columns at this level. So we can alter and build our grid object to have 6 columns. A couple pros for this, it simplifies our code base. There is less code to manage. There are less files to deal with. And changes to your grid object, if you need to go in and make a change, it's all right there. It's in one file. It's very easy to see. Things are very close in proximity to each other. One negative to this, though, is visibility of those changes are not noticeable. You can't see them at the file structure level, right? If you were to open up the folder structure and see the files in your code base, you would not know at first blush that the grid changes across breakpoints. You have to actually open the file to see that. However, that option can be very nice for more simplified websites, right? You don't want to add complexity for the sake of complexity. Our second option is to enhance our grid object, right? So we want to add a few more files. Yeah, more files. So here, using our naming convention, we've got small, medium, and large. Those are reflective of our viewports, our small, medium, and large viewport. Separate files manage variation in our object across media queries. However, now we get the media queries out of our files and we put them somewhere else, which we'll look at in a moment. But this really adds a new profound layer of flexibility to our code, right? So we have more simplified code inside of our files. And let's say you're using a task runner. Like, you could theoretically pull different files out at different points and put them in different places and distribute your code differently. So really, we've got the story of Grid as he grows up, goes to school and graduates high school. So we're enhancing and we're changing and we're building upon Grid as we go across viewports. So another way to think about this is we've taken our separation of concerns idea and we've applied it to our actual code base, like our files in our code base. We're separating out the concerns of each media query in our Grid object. One con to this approach is if you do want to see what's happening at different breakpoints, you kind of have to pull up 2 files and put them next to each other. So now you can see grid and then grid small next to each other. It's not a terrible hurdle to solve. Our IDEs will let us do kind of that multi-pane now, so that's a pretty quick sell. But there is one more step to finish this out. And Looking at our code base now, we've added a few more files, and if you look down at the bottom, you'll see our screen files. These map just directly to the viewport naming convention, right? So our grid file will be imported into screen. Our grid small is imported into screen small, etc. All the way down until we get to our style.scss file, and here's what that looks like. This is cool because we've consolidated all of our media queries into a single file. That's a big deal, right? All of our media queries are out of our code base. They're in one single place. And we've imported all of these different files that do different things in the same object across different breakpoints. They don't care about the media query anymore. We've made our media queries more maintainable, right? We can go to one place and change them, and now we've affected our entire code base without having to go into every single object file and update our media query. Cool. What about legacy support? Well, same deal. First option's a hack. We all love hacks. Second option is our same multi-file approach. So looking at the first one, what does grid look like as a single file supporting legacy browsers? Well, it's pretty easy, right? We've got our simple file here from before. We add in a media query hack to target IE8 only. Cool. That wasn't so bad, right? We've now, with a single file, supported IE8 without ever having to actually conditionally include another CSS file in our DOM, right? We don't have to do if less than or equal to IE8 load this other style sheet. It's the same style sheet. It's all built right in. That's kind of cool. Same pros as before. Our object changes are within close proximity. We're dealing with everything grid has to handle all in one file, which is nice. We are retaining access to our cascade by doing this. By keeping grid in the same file as your entire grid object, you get to use the cascade as it loads line by line by line. Your CSS is maintaining that cascade. So perhaps you have a few less properties in your IE8 only like overrides than maybe you would if you had to pull it out into a separate file, load it later, right? Some cons to this approach. Again, same one with the visibility into where our legacy support is lost when you look at purely the files and the folders. And perhaps maybe multiple legacy browser support, that gets really muddy, right? Are you supporting IE8 and IE7? Putting both of those hacks in a whole bunch of different files in your code base, that gets a little muddy. So our second option is very similar to our responsive way of doing this with multi-files, right? So we'll separate out IE8 into its own file, and we're going to replace our style.scss file with two more. We've got modern and we've got legacy. So now we're actually breaking out two separate CSS files that get compiled and generated with Sass. We are still utilizing the cascade, however, because modern CSS is loaded first in the browser, and then IE8 overrides are applied in IE8 only when they need to be. So let's look at our code base again. We're kind of building up to the big finish here. Why is screen CSS not loaded in our legacy file? Well, here we have small, medium, and large. Like, where's screen? We do see our IE8 grid file is pulled in there. Well, we get screen automatically with modern. Okay, because screen was in modern to begin with and it was not in a media query, IE8 will read it and it'll render it. So you've got everything you've built in screen pulling up in your browser, even in IE8. All the rest of those three, small, medium, large, those are baked into media queries, which IE8 is not going to read. So we repeat them here and spit them all out for IE8 only. It has to deal with that extra file. Okay, one final review. We've got methodology, we've got objects, we've talked about structure. So, well, we'll get to it, right? Here's everything we've looked at so far. In a second, we're going to go back to our little friend, the grid object. But first, notice here we've introduced a few more files. Okay, we've got a helpers file at the root level inside of a helpers folder. We've also got a variables and a helpers file inside of our object folder, so halfway down the page there. And this is where Sass gets to really bring our code base to life and where it will fix those two problems we were having before of maintainability and interoperability. So remember, we're attempting to resolve a few things that we dealt with earlier. Maintainability, we want to find a way in our CSS to add some maintenance or some maintainability to the code base. So if we want to come in and make a change, it's way easier to do because we're going to use things like variables and functions, and that adds the programmatic part to CSS that we've been missing. All right, so we're going to ease into this a little bit, and we'll start with just a very few, I'm sorry, go back a second here. Start with a few static variables. All right, so these would be considered kind of your global level variables, things that are kind of constant and don't change. They are inside of our variables file inside a grid because they've been namespaced to signify they really only deal with our grid object. Okay, so we're applying object level variable naming conventions here to say that these three are only going to deal with grid. We've got our viewport, that's grid width, that's specified with pixels but without the px on the end. Our grid gutter, again 24 pixels is what we want coming through our gutter. And we've got 4 columns. We're going to build out our object. And why pixels? Well, when you build a design in Photoshop, you're designing in pixels. So why not make it easy for your developer and your designer to communicate in the same language, right? So instead of saying 100% width, let's use the actual pixels that it was designed for in the comp, because we can use Sass to calculate all the percentages for us. So this is a far more maintainable way to make modifications to your grid going forward. Helpers. We are going to generate 2 new variables with our helpers, okay? Yay for Sass. Based on our 3 variables from before, we're going to calculate 2 additional ones. What we want out of this is a percentage-based version of our gutter. So before we had a pixel-based version, 24 pixels. We want that represented as a percent. And we want a percentage-based version of our column. So how wide is a column represented as a percentage? We're going to calculate those because Sass lets us do that. So buckle up for this one. There's a lot of code on the screen here. Really what we're concerned about is those 2 guys, okay? So everything else around there is just defense. All right, if you're going to use Sass, Sass is built in a way for us to conditionally deal with situations when we're generating variables and running functions. We potentially will get like undesirable or unpredicted results. Maybe we're returning, you know, like -0 or something out of our variable calculation. So all the rest of the gray there is defense. Reading through it real quick, if our 3 variables we pass in are unitless, we're going to generate those 2 variables we need. If it ends up being a 0, we're just going to return 0 instead of 0%. If that's not the case, we're going to warn the user in their build process that something went wrong so they can find the location and fix it. And we're going to reset some fallbacks because we don't really know what to do with those calculations otherwise. All right. Another one in local helpers is column width. This is a function that will generate the percentage of our columns. Okay, so we don't need to get into the math going on here, but we're going to use the 2 variables we just calculated, so grid gutter and grid call. We're going to pass in, so the n variable we're passing into the function, that is the number of columns we want. Do we want to generate the percent of 1 column? Do we want to generate the percent of 2, 3, or 4? So you're passing in a single number, and what you're going to get returned is a percentage-based version of that column. And here we're using strip units, which is a function we'll look at in just a moment. I just want to call that out here, that what strip units does is pulls the units off of a number. It's as simple as that. And again, that is a little piece of defense. If for some reason you pass in a number for n that is not a single number, it'll strip the units off so the rest of the function will return properly. All right, so that was local helpers. Now we're going to look at our global helpers. And this is the distinction. Global helpers are things that you can use all over your code base. All right, they don't necessarily mean for them to be used in a single object. All right, so we're going to put them in a different place. And these should be familiar. Clear fix, we saw that earlier. We're just going to make a mixin out of that. It's going to make it a lot more maintainable to use. Here's our strip units guy. We're going to talk about that. And then get, pair, and offset. Just going to get in the weeds, but it'll be fun. We're going to build one mixin, which we can add include everywhere else, and 2 functions that are going to generate some numbers for us. So first of all, our global helpers. This is the exact same clear fix that we saw earlier. We've just now made a mixin out of it. So guess what we get to do? We get to blow that little B away. All right, we've gotten rid of them. Cool. We're making progress. Remember, this is a IE8 Plus clear fix, so it does support the way we're building our grid. Just keep that in mind, though. Our next one, strip units. Like I mentioned before, you pass in any number with units, pixels, ems, percentage, whatever it is, any unit gets passed in. What you get back is the number without the units. Very simple function. And finally, get parent offset. We're going to spend a little bit of time digesting this one because it does require some crazy math. This function is only necessary, so keep this in mind, it's only necessary when you are using columns and gutters that you want represented as percentages. Okay, so they both need to be percents. That's when this comes into play. G, our variable here, is the desired gutter width between the columns passed in as a percentage. Okay, so remember we calculated that percentage before. That's our grid gutter variable that we calculated with our local helpers. So we have that already, and we're going to pass that into this getParentOffset function. So let me illustrate what this looks like for you. Using pixels, building a grid, you have 960 for the viewport, you have this -24 margin on there, all well and good, right? You put a +24 margin left on your columns. So once you get into the children of your object, our grid columns, each one gets a positive 24 pixel margin on the left, which that first one offsets the -24 from the parent. So now that first one lines up real nice and clean with the edge of your parent, right? You don't have the gap of margin inside of your parent. That's why this is a resilient object. If you have 5 columns show up in here, the next one will float down to the bottom, and it'll still have that -24 offset outside of its parent, and it'll line up real nice and solid with the one right above it. So when you have pixels, it's no big deal. Use the same number. Great. Well, when you're dealing with percentage-based grids, the container and the children have to deal with percentages differently, right? Percentages is a relative unit of measurement, okay? So 100% of a thing is not the same number of pixels as 100% of another thing. So we have to keep that in mind and deal with that in our Sass. So the parent offset, which is that negative margin on our parent, is not simply the gutter of the children anymore when you're talking about percentages. Because the width of the child elements, so that's all of our columns, plus the total number of gutters of all of our children, is equal to the total width of the parent object plus the negative margin of the parent object, okay? So we're going to look at how to do that in just a moment. We have to derive our pixel-based offset. So the goal is to still get 24 in both, all right? But we can't do it with as simple a function when we're using percentages. So we'll step through how to do that. Here's where we land with our parent, right? Looking at our children, our columns, we've got 100% now is equal to our 960 plus the 24. Okay, so when you're talking about the children, you're building out your columns. What you're doing is math with 24 and 984, which is different than when you're doing the math with your parent. So the gutter and the column are still calculated off 100%, but at this level they mean different things. All right, when we calculate the percentage of columns and their grid, the intent behind all this is to still get that 24 pixels at the end of the day. But what actually happens is instead of 2.5% on our parent, when you're talking about columns, it actually translates out to 2.439%. Go figure, right? So the getParentOffset function does this for us. Okay, that's the whole reason that we have that, is it does all this math for us. That makes our code base very maintainable and interoperable. Someone can jump in, I want 5 columns, run the functions, it's all good to go, right? So let's bring it all back together. First, we're going to import our local variables. We're going to import our local helpers for our grid. We still got our parent, but now look, we're using our getParentOffset, right, to calculate that margin. We're passing in that calculated variable of the gutter, so that is a percentage being passed into our getParentOffset. That will give us the -2.5%, which we want on our parent. We've got our clear fix in there, using a mix-in for that. When we get into our child, our grid column, we're still floating that left. That hasn't changed. Now we're using our column width function to generate a percentage base part of our column. So it's going to give us width as a percentage. And we've used that calculated gutter for our margin left, which is the negative 2.439, right? So now we've used these generated variables to really enhance our code base. And finally, we're going to actually use Sass in a cool way to generate our columns. We don't know how many columns there are, we don't know how many you want, and maybe you want to change how many columns you have across breakpoints. Well, we can handle that with this simple function. If your grid columns is greater than 1, so we want more than 1 column, we're going to run a for loop, and for every I from 1 through the number of columns you specify, so we're going to run this 4 times, we're going to build out this selector, which using Sass, that's just kind of the syntax of using the item at the moment inside of your selector. This will give us grid-call underscore, and then 1 of 4, 2 of 4, 3 of 4, 4 of 4. And every time we do that, we're going to pass in our 1, 2, 3, 4 into our column width and generate our percentage-based width for each column. Super handy, and we get rid of all those B's, all right? Now we've got a way to programmatically and maintainably build out a grid that we can pass in any numbers to, and it'll just generate it all for us. It's pretty cool. So we're not going to look at our additional files like the small, medium, or large. It's just going to get a little too deep. But what we get to do here is, let's say at the small size, you want an 8-column grid. No big deal. You import your variables and your helpers, you redefine your columns, so I want 8 instead of 4, and you just rerun these 2 functions in your small file. Now you've got the exact same grid, exact same selectors that are only applied to the small media query. Okay, that's a pretty cool thing. All right, deep breath. We got through the weeds. We're going to come back real quick and just test out our theory again, all right? So did we make our code base better by using Sass? Same deal with semantics and accessibility, predictability, release all these guys, and hey, look, our code is now maintainable, okay? Now let's assume we put a bunch of nice comments in there to describe the variables and how the functions work and all that. Now we've got a very maintainable grid that we can actually pick up out of that project and throw it in another project, put in your variables, and it's going to work, right? That's a very maintainable solution for your code. Still performant, and now we've also built in interoperability. Hooray! Anyone can come into this code base and they can tweak a variable, run your build, and they don't have to worry about anything else, right? That's a very simple thing that you can just pop around. All right, so what are the benefits of this kind of architecture, right? We looked at a lot of code today, but really what we're trying to get at is making smart choices, okay? We want to build code bases that we can like enjoy working with, all right? So we want to look at that. What did we get out of this? Well, we've got understandable, predictable, maintainable. Those are all very happy words to a developer. Like you say those things and throw them some code and they're like, yeah, that's super fun to work in. We've also built in interoperability, especially at scale, all right? We have a lot of people working on a project. You've built in this interoperability by using Sass, applying your methodology, providing some structure. Repetitive decisions like, where does this file go? I don't really understand this file structure. Like, those are done for you already, okay? So if you're going to build a new object, you already have categories. You know exactly where those things need to go. That actually speeds up your time quite a bit. We've let you develop faster. If we make those small decisions for you, like I got to build a new code base from the ground up for a new project, we've actually done that already for you. This idea can be used on any project, right? So we've increased your speed in development. We've also increased the access speed for certain bits of code. Where's my grid? I know exactly where to go find that in my code base, right? Where's my button? I know it's in the content folder. I can go find that right away. And by increasing your access speed, you actually make code review easier. If part of your job is code reviewing other developers' code, you know where to go find their code. You know what intention a certain object should have. You've provided that structure to your code base as well. And most importantly, we've gotten rid of all of our B's. All right, we don't want any code B's. So, does this stuff work? I'm here to tell you that it does. Okay, we've got 250 developers at the Nerdery. We've got 60 client-side developers. Those are people writing HTML, CSS, and front end. We have somewhere around 400 projects running at a single time on any given day. Okay, that is a lot of code coming through our company. So we've developed these standards, and you can find them here at this link. we've proven that this kind of structure works. Like, we use something very similar to what you're seeing here. It's probably no different than what you'll read on our standards there, but what we've done is provided a way for our developers. Now, granted, you take away a little bit of freedom, right? So you say, you're going to build code at our site, at our company. You're going to work on projects. We need you to build it this way. And the reason we say that is because we need to be interoperable. We need to say, your team of developers is done with phase 1 of that project, but phase 2 is going to go to these guys, right? And they have to know what your code is doing in order to pick it up and make that second phase like an enjoyable experience for the client. If you have a bunch of developers like, what the heck is going on with this code, or the client is developers, and we have 2 different ideas going on in our code here, that's not helpful for anybody. So, take a look at our standards. We actually just published them out this week. It's very exciting for us at the Nerdery to be able to share this out with you guys. And thank you very much for coming today.